Today, we're going on a hunt. We're diving deep into the genetics of one of the world's most beloved foods, the tomato. And we're going to see how scientists are racing to protect it from a hidden threat that's, well, it's growing every single day. Now, I know that sounds a little dramatic, but it's a very real question. The future of the humble tomato is facing a huge challenge. And the key to saving it? Well, it might just be hidden deep inside its own DNA. So what exactly is this invisible enemy? Well, it's something we usually associate with the ocean, but it's quietly creeping into our farmland and causing some serious problems. The core of the problem is salt. Simple as that. As climate change shifts our weather patterns, more and more of the land we use for farming is becoming too salty for crops like tomatoes to handle. You see, for a plant, high salinity is like fighting a war on two fronts. First, you've got something called osmotic stress, which basically means the salt in the soil literally pulls water out of the plant's roots. It's dehydrating it from the ground up. And if that wasn't bad enough, it also causes ion toxicity, where elements like sodium build up to poisonous levels inside the plant itself. It's a brutal combination. So, to fight back against this, scientists came up with a really fascinating mission. They decided to put a whole bunch of tomatoes through a brutal stress test to see if any of them, just maybe, had a genetic secret to survival. And we're not talking about just a few plants from the local garden center. No way. Researchers from the University of Arkansas gathered this massive genetic library, 265 different tomato varieties, brought in from 35 countries, all to find the toughest of the tough. The process was incredibly methodical. First, they grew all these seedlings under perfect conditions. Then, they hit them with a daily dose of super salty water every day for 2 weeks straight. All the while, they were meticulously measuring exactly how the plants were reacting, and this is the crucial part. They analyzed the DNA of every single one. And the results were, well, they were stark. I mean, just look at the difference. You can see this huge range in how the plants responded. A lot of them just withered away under the salt attack. But then you have these other guys, these few special varieties that just stood strong, showing this incredible resilience. That visible difference was the very first clue that some powerful genetics were at play here. Now, to make sure this was all objective, the scientists didn't just eyeball it. They used really precise metrics. They scored any visible leaf damage on a scale from 1 to 7. They measured chlorophyll to see how well the plants could still make food for themselves, and they tracked seedling height to see just how much the salt was stunting their growth. Okay, so now they've got all this performance data. Who survived, who didn't, and by how much. The next step was to go digital. It was time to hunt through billions of genetic data points to find the exact bit of code responsible for that salt-fighting superpower. The tool they used for this hunt is called a genome-wide association study, or GWA. And the analogy of a search engine for DNA is absolutely perfect. It scans and compares the entire genetic code of the tough tomatoes against the code of the weak ones, looking for the specific genetic keywords that are consistently linked to survival. So what are these keywords? Well, they're called SNPs, or single nucleotide polymorphisms. But honestly, just think of them as single letter differences in the DNA instruction manual. A tiny typo. The GWAS was basically looking for the specific typos that turned a regular tomato into a super survivor. And here it is. This is the genetic treasure map. It's called a Manhattan plot. Every single dot you see is a genetic marker, all laid out across the tomato's 12 chromosomes. The higher a dot is, the stronger its connection to salt tolerance. And those peaks, the ones shooting way up past that red line, those are our hotspots. Those are the most promising clues in the entire genome. So after sifting through literally tens of thousands of possibilities, the entire massive search, it all zeroed in on just 8. That's it. 8 crucial genetic markers that kept showing up in the tomatoes that could take the heat, or in this case, the salt. But, even among those 8, there was one clear superstar. A single SNP, one genetic marker on chromosome 5, turned out to be the real MVP. It was strongly linked to the 2 most important survival traits, keeping leaves healthy and green, and resisting that physical damage from the salt. Now, finding these markers is a massive breakthrough, don't get me wrong, but the real power, the real magic, comes from how we can apply this knowledge to build a real practical solution. You see, this discovery unlocks a technique called genomic prediction, which means instead of just identifying plants that are already salt tolerant, we can now predict it just by looking at a tiny seedling's DNA.
And this is a total game changer. Think about it. Traditional breeding takes forever. You have to grow a plant for months, sometimes years, just to see if it has the trait you want. But with genomic prediction, you can test a tiny piece of a leaf from a seedling and know almost instantly if it has the genetic potential to be a salt-tolerant superstar. It's fast, it's precise, and it's all driven by data. This chart just drives the point home. Look at the bar on the left. That's the prediction accuracy you get if you just use thousands of random genetic markers. It's okay. But now look at the bar on the right. By using only those 8 key markers we found, the accuracy jumps way up. It's proof that having the right genetic information is so much more powerful than just having a lot of it. Okay, so let's pull back for a second. We've seen the problem, we've seen the experiment, and we've found the genetic solution. But what does all of this really mean for our food supply and for us? Because, yeah, this study focused on one very beloved fruit, but the implications here are absolutely massive. The technology and the approach, that's what truly matters.
You know, the researchers themselves put it best. They said they've provided valuable tools for a new era of what's called molecular breeding. This is essentially a blueprint for creating crops that can not only survive, but actually thrive on a planet that's under more and more stress. So what's the big takeaway here? It's really a fundamental shift in how we approach farming. Instead of waiting years to see if a crop can handle new challenges, we can now predict it right from its DNA. This speeds up the breeding process like you wouldn't believe. But more importantly, this exact same approach can be used for other critical crops, think wheat or rice or corn. It's a vital tool for proactively designing crops for a changing world, and ultimately for securing our future food supply.
It really makes you think, doesn't it? With this genetic toolkit, we now have the power to be architects of the crops of the future. So the question isn't just if we can do it anymore. The question is, what should we focus on next to secure our food for generations to come? That's a question we're all going to need to help answer.